This is one more example. Let's try to prove this. Once again, if you observe this very carefully, you can see here that the left side consists of sec A term and tan A term. The right side consists of 1 minus sin A term divided by 1 plus sin A term. So it is very obvious that you want to express the terms on the left hand side in terms of sine and cosine terms. So let's get started. So first of all, let's consider the left hand side. So this is equal to sec A minus tan A whole square. So I'm going to write this in terms of sine and cos terms. That is the most important hint. So sec A can be written as 1 by cos A minus tan A can be written as sine A divided by cos A whole square. Now if you look at the LCM happens to be cos A and the numerator will be 1 minus sine A this whole square. Now, we know one important property of mathematical terms. So, if I have something like a by b whole square, I can write this as a square divided by b square. So, I'm going to make use of this property and then write it as 1 minus sine a whole square divided by the square of denominator. That means cos square a. Now, if you observe the terms we have been able to get in terms of sine and cos, but the denominator consists of 1 plus sine a. So what we do is we try to write the denominator cos in terms of sine. We know the identity, that is sine square a plus cos square a is equal to 1. So I'm going to substitute the denominator like this. Numerator is intact, 1 minus sine a whole square divided by cos square a can be now written as 1 minus sin square a. So the denominator now becomes 1 minus sin square a. Please observe that the numerator and denominator terms are very different. So the denominator term is like 1 minus sin square a. So this is nothing but 1 square minus sin square a. I can write it as 1 square because 1 square is just 1. So this is how I can indicate it. So you can see here that this is of the form a square minus b square. So which can be very easily written as a plus b into a minus b. So I'm going to rewrite this now. So 1 minus sine a whole square is there. So can I write this as 1 minus sine a to 1 minus sine a? Yes, then in the denominator, I'm going to write it as a plus b into a minus b. The value of a is 1, and then b term is sine a itself into 1 minus b. A is 1 minus b. B is sine a itself. So if you observe these terms very carefully, we have 1 minus sine a, 1 minus sine a, divided by 1 plus sine a into 1 minus sine a. So the 1 minus sine a, this term gets cancelled out. So I'm left with only 1 minus sine a divided by 1 plus sine a. So this is equal to RHS, and hence the identity is proved.